All right, here's a video that's going to help you with Chapter 3V review. So this chapter is mostly about matrices. So as we go through, we're just going to give you little tips here and there that are going to help you to do these questions a little bit better. Okay, so number 3 is the first one I want to look at. Number 3 gives you 4 matrices to start. And my tip here is when working with more than just 2 matrices, it's a good idea to type all 4 in your calculator before attempting to perform the given operations. Okay, so with that, let's pull out our calculators. And I've already typed in the first 3, and I'm going to show you how to type in the last one. So the last one being D right there. I'm going to go arrow over to edit. And just for reference, to get to this menu, all you got to do is hit second x to the -1. So second x to the -1 is your matrix menu. So I'm going to edit my 4th matrix, E. Okay, and the first thing it's going to ask me to do is to enter the dimensions. Okay, the dimensions are always row first by column. So the rows are horizontal. So there are 1, 2, 3 rows, and there are 1, 2, 3 columns. So that shouldn't be too difficult to say 3 by 3 matrix. There's nothing too crazy there. So once again, pulling this out, I'm gonna enter 3 by 3 for my dimensions, and then I just have to toggle through and say 3, enter, and it's gonna go by rows. 6, enter, 4, enter, 12, enter, and this is the easiest way to input a matrix into your calculator, because once you just do this legwork here, and then I'm going to look at it real quick and just make sure it looks like I want it to look. 3, -13, 6, 4, 12, 6, -2, 0, 5. So I know I'm pretty good here. So from there, I go back to my matrix menu, and I see I got A, B, C, D, and E, or sorry, not E, but A, B, C, and D, all in that matrix. So at this point, I just want to solve these equations that I'm working with. All right, so you got 2A plus 4B. So in your window here, you just go 2, and then you go back to the matrix menu and you pull matrix A. So that's going to be 2 times matrix A plus 4. And I'm going to go back to my matrix menu. I'm going to pull matrix B. So you see how easy this becomes when you have all the matrices typed in. So you don't even really have to do a ton of work here to get your answer, which would be, in this case, 4, 8, 10, 30. So you can see that's the answer to 2A plus 4B. Same thing for the next one. So once again, once I have all the matrices in there, it's 1/2 C plus D. So I'm going to go over here and just do 1/2. So I'm going to type it in, just go 0.5 parentheses, go back to my matrix menu, pull C, and then add matrix D. All right, so there's nothing too crazy about this, just a matter of putting that time in the beginning to get your answer. So it's going to be 2, -6.51. You're going to get 2, 7.54. And then your last row is -3.5, -1, and 6. So you can see that your answers are given pretty easily by plugging those in from the get-go. So once again, typing them in your calculator is your best bet for those particular types of questions. So next question I want to look at is number 6. Okay, use matrices to set up an augmented matrix and solve the system. So this is going to be one of the most useful skills, I guess, from this section as far as what you're going to maybe use next year and actually to solve word problems and things like that. So what you have to do first is rewrite the 3-variable system as a 3 by 4 matrix, okay? And you got to be very careful about this, okay? What you have to make sure of is there is an X column, a Y column, a Z column, and a constants column, okay? It's 3 by 4, so that means there are 3 rows, 3 horizontal rows, and then 4 vertical columns. So the X column has to have something in each place. So if there's no X in the equation, then it's just going to be a 0. So I'm going to write the first equation, which is 3x, -1y, 1z, and then the constant is 1. So you see how I just wrote the coefficients of everything in that first row of my matrix. The next one is 2x. It's got no y, so it's 0y, -3z, and -14. Okay, and then the last column you have 0 for x, 5 for y, 2 is your coefficient for z, and 8 is your constant. So you see, be careful when you're setting this up, because that's your biggest thing. If you could do that, all you got to do from here is a bunch of calculator work, okay? So pulling this out, just gonna move this a little bit over so I can see my calculator. But at this point, all I have to do is go to my matrix menu again, and I'm just going to use any of these matrices. It doesn't really matter. I'm going to edit this one. And my dimensions are 3 by 4, so 3 by 4. And I'm going to enter the matrix that I just created. So just kind of get rid of the boxes. You got 3 for your first one, -1, 1, 1. So there's my first row. My next row is 2, 0, -3, -14. If you notice, I'm not worried about what's already there. There's going to be stuff there. It's okay. If you just type, you'll overwrite it, and it won't be an issue. So you don't have to worry about, like, how do you delete it? It's always a question students ask, like, how do I get rid of the stuff that's there? You don't have to worry about it. Just make sure you just hit the number you want and hit enter, and it'll replace whatever was there. So in this case, you got your 3 by 4 matrix in there. I called it matrix A. So now the last thing you have to do is the operation that we learned was the reduced row echelon form. So if I go back to my matrix menu, and then in math, there's a bunch of things that you can do to a matrix, okay? You can take the determinant, you can find the identity matrix, you can create an augmented matrix if you wanted to. The one that I want to use is RREF. That stands for reduced row echelon form. If you've never heard that word before, RREF, you've seen a bunch of times. So I'm going to RREF matrix A, okay? And then I'm going to get my resulting matrix. So what you see there, you get the identity matrix for your first 3 by 3 matrix, and you got -1, 0, and 4. So let's see what that means. So you got -1, 0, and 4. So what that means is that your x column gives you -1. So this basically corresponds to the equation x equals -1. This would be 0x, 1y, 0z, and y equals 0. So this is 0x, 0y, 1z equals 4. So you can see your answer is just x -1, y 0, and z 4 if you want to write it as a point, because what essentially you found was the intersection of 3 lines in space to be -1, 0, and 4. So you can kind of see how that works and how the reduced row echelon form tells you the solution to the system. That's a very valuable skill to have, so you're going to need to know that for other things. But you can see how that works. The next one I want to look at is 7. And for this, it says find the value of the determinant without a calculator. That's very important. There are going to be questions on this test that you need to know how to do this without a calculator. And you're like, well, I have my calculator. I know how I can use it. Well, there's ways to kind of ask you questions that you don't have the ability to use your calculator on. So you need to know how to find the determinant of a 2 by 2 matrix. And it's actually very simple. You just remember that you multiply it -2 times 8. And you subtract 5 times 6. That's a 5, by the way. So this is what I get. So I get -16 minus 30, which actually gives me a determinant of -46. All right, so from there, let's move on. Do number 9. So here's a matrix equation where you say one matrix times another matrix equals a result. When you do this, what's interesting is you have to make sure you multiply by what we call the inverse. So this is for matrix equation, A times matrix X equals matrix B. Multiply both sides by A inverse so that X equals A inverse times B. So this is kind of a concept that seems kind of foreign, but it's just, again, essentially just a calculator question. So I write it symbolically, and I'm going to call it AX equals B. So then if I multiply both sides by A inverse, you see what's going to happen is A inverse times A. The inverse of anything times itself is going to give you 1. And that's why inverse of A inverse times A gives me just X. This part here just kind of cancels out. So then you see that X equals A inverse times B. So what I'm going to do is I'm going to type both equations in my calculator, both matrices in my calculator, call one matrix A, one matrix B, and then I'm going to find the inverse. And it's actually not too difficult to find the inverse, so we'll show you how that works. So in my calculator, I'm going to type my 2 by 2 matrices. So this one's already 2 by 2, so I don't have to retype the dimensions, but I'm going to retype the values. Okay, so I get 2, 3, -1, 5. I'm going to check it. Looks good. I'm going to go back. I'm going to edit matrix B. And that one is again 2 by 2, so I don't have to retype the dimensions. But my values are changed, so it's 8, negative 20, negative 4, and negative 42. All right. So now, at this point, it's a matter of just typing in my calculator. I have to type A inverse. So I'm going to take matrix A. And the real simple inverse, it's the matrix button, but I don't hit second. So A inverse times matrix B. And that's going to give me the answer for the matrix X. Again, my answer to this question, you have to understand, is another matrix. Okay? So A inverse times B is 4, 2, 0, negative 8. So what you see here is that X equals the matrix 4, 2, 0, negative 8. And what that tells me is that if I take matrix 2, 3, negative 1, 5 times that matrix, I should get 8, negative 20, negative 4. So there's a real easy way to check this. If I go here and I take matrix A times that result right there, okay? So matrix, I'm going to say it's second answer. And if you see that, it should give you the result matrix. And that it is in fact true. So again, my answer to the question is a matrix, and the way you find it is by taking the inverse times the both sides. So the inverse of matrix A times both sides. So moving on. Number 10 is find the area of a triangle whose vertices are located at negative 1, 6, 2, 4, and 0, 0. This is a skill that you just need to know. So the area of a triangle is given by plus or minus 1/2. And I say the plus or minus because whatever you get, if it's positive, it's positive. If it's negative, you got to make sure that you take it and make it positive because area can't be negative. But the way you write this is you take the determinant. So the straight bars, instead of like, if you curve them in, that's a matrix. If I just do straight bars, that indicates determinant. So I'm going to type the ordered pairs in there in columns 1 and 2. In my third column, I fill with 1s. And this is just a process that you need to know. So what I'm going to do is I'm going to type this 3 by 3 matrix in my calculator. So again, I'm going to go matrix. I'm going to edit matrix A just because it's easy. And again, you're going to keep changing matrix A, and it's okay. And just overwrite. You don't have to delete. Just overwrite what's there. Okay? So here's matrix A. And I don't want anything other than the determinant of matrix A. So what you got here is I'm going to say 0.5 times second matrix. I'm going to take math determinant, go back to my matrix menu, and grab matrix A. So I'm going to take 0.5 times the determinant of matrix A, and that's actually going to tell me the area. So it's negative 8. Well, we said already that you got to make sure that if it's negative, that you turn it into positive. So the area would be 8 units squared. You're talking about area, so you're talking about units squared. So that's the process of finding the area of a triangle given the vertices in the coordinate plane. This is a cool matrix application. It has some pretty cool applications. So last question that I want to talk about is number 13. And number 13 is probably the trickiest question. And on the test, it's going to be a tricky question as well. So on number 13, it says a shoe company produces 3 types of running shoes. One's a sprinter, one is for distance, and the last type is for field. The Fast Club track team has 42 members and orders a shipment of shoes for the national meet. The sprinter shoe costs 40, the distance shoe costs 50, and the field shoe is 100. There are 3 times as many sprinters as distance runners. The team's total bill is $1,900. So what you have to come up with are 3 equations. Okay, this is not your typical system where you come up with 2 equations and solve it using substitution or elimination. This one has come up with 3 equations and then use your calculator with RREF and do all that. So I need 3 equations, okay? So let's see where we're going to get our 3 equations from. So you like, okay, so the team has 42 members, and there are 3 types of shoes. So I'm going to call them S would be the sprinter shoe. Okay, and when I say S, I'm talking about the number of sprinter shoes. Okay, we're going to call the next one D would be the distance shoe, number of distance shoes, and then F would be the field shoes. Okay, so I know that the total number of sprinter shoes plus distance shoes plus field shoes are going to equal the total number of members of the team. That's going to be one equation that you need to know. So there's one of my 3 equations. Okay, and if you're like, how did you know that? You know, practice these. There's gonna always be 3 equations, and you just gotta start thinking like, well, okay, if I got this number sprinter shoes, this number distance shoes, this number field shoes, I know the total number has to be the number of members of the team. Therefore, it's gonna be 42. Okay, so now the next thing you want to do is like we did with other systems, is you want to keep your money together. Okay, you got a certain amount of money for each type of shoe. You got $42 or $40 for the sprinter, 50 for the distance, and 100 for the field shoe, and your total bill is $1,900. Keep your money together. Okay, so it's going to be $40 for each sprinter, plus $50 for each distance, plus $100 for each field shoe, and the total bill was $1,900. Okay, so there's equation number 2. So now there's always going to be a third equation. This is the one that's kind of different because I have 3 variables. I need 3 equations. If you had 4 variables, you need 4 equations to solve. So you got 3 variables, 3 equations. The third equation is given by this sentence right here. It says there are 3 times as many sprinters as distance runners. Okay, so there are 3 times as many sprinters as distance runners. So what does that mean? That means like if there are 5, or let's say 15 sprinters, then there would be 5 distance runners. So there are 3 times as many distance runners. So 3 times the number of distance runners equals, 3 times the number of sprinters. No, I should say it that way. 3 times the number of distance runners equals the number of sprinters. And it's because I could think about it. If I put in, wait, let's think about this again. So that's your tricky equation here. You see how I'm a math teacher, I'm kind of like thinking about it for a second. There are 3 times as many sprinters as distance runners. So I'm going to set up an equation, and then I'm just going to think about it, because this isn't something that there's like this is the way you do it every single time. I still need to think about it. I'm a math teacher. So I say 3 times as many sprinters as distance runners, okay? So if there are 5 sprinters, then that would be 15 distance runners. Is that true? Probably not, right? So if there are 5 sprinters, there should be 3 times as many sprinters. So if there are 5 sprinters, that doesn't mean there are 15 distance runners. It's the other way around. So if I'm going to set this up, I'm going to set it up 3 times distance runners equals the number of sprinters. So again, I got 3 times, if there were 5 distance runners, then there would be 15 sprinters, and that one makes kind of sense. So just kind of thinking about it, that's going to be the way you solve the equation. So for that last equation, though, I want to make it look like the other ones. So I got to have a constant on the other side. In this case, the constant is simply just going to be 0. So in this particular equation, it's going to be 3D negative S plus 3D plus 0F equals 0. No field runners in that particular equation. So my 3 equations, if I can come up with, if you remember what we did there, will be right here. So now I'm going to write a matrix, an augmented matrix, and I'm going to type it in my calculator. I'm going to do RREF. I'm going to find the number of each type of runner. So the first equation has coefficients of 1, 1, 1, and a constant of 42. All right, the next one has 40, 50, 100, and a constant of 1900. The next one is -1, 3, 0, and a constant of 0. All right, I'm going to type that in my calculator, and I'm going to do RREF. Since we already did that, I'm going to actually let you guys do that on your own. But because the hard part, again, was coming up with the equations, okay? This is the difficult part, okay? And actually, the first 2 equations, I didn't actually find that difficult. It's this last one that you really need to think about. It's the last one that you kind of say, okay, if I have 3 times as many sprinters as distance runners, how does that equation play out? All right, so I hope this helps you with your review, and you ace this test.